In this video, we're going to take a look at some counting rules. So it turns out that counting the number of objects in certain scenarios is actually can be quite difficult. And so we're going to take a look at 5 rules that are going to help us make these calculations. And we'll start with something pretty simple here. So if any one of k different mutually exclusive and collectively exhaustive events can occur on each of n trials, the number of possible outcomes is k to the n. That should have been is. Let's take a look at an example that is not as complicated as it originally sounds. So let's just take a look at an example on what that actually means. Let's suppose we roll a 6-sided die 4 times. How many outcomes can we get? So, pretty straightforward question there. Well, we have 4 dice that we roll, and 4 6-sided dice that we roll. And so the number of outcomes is, here we get k is equal to 6, n is equal to 4, because there are 6 outcomes for each of the 4 trials that can occur. And so there are 6 to the 4th, which is the same as 36 squared, which is 1,296 possibilities. All right, now here, let's be clear on something. The outcome of 1, 2, 1, and then a 1 is different than a 2, and then a 1, and then a 1, and then a 1. So even though if we rolled a 1, then a 2, then a 1, then a 1, that's the same total as a 2 and a 3 1s here. But the fact that we rolled the 2 on the second roll relative to the first roll makes these different outcomes. So if we're counting those as different, then this is the number of total possibilities here. Later on, we'll look at how to count when these are not different, but we're not doing that right now. So let's take a look at our second rule, right? This is our first rule up here. Let's take a look at a second rule, and that is that if there are k sub 1 events on the first trial, k2 events on the second trial, all the way up to k sub n events on the nth trial, then the number of possible outcomes is k sub 1 times k sub 2 times everything all the way up to k sub n. So that is our total number of outcomes if we have k sub I different events occurring for the ith trial. So let's take a look at an example where something like this might occur. Well, let's suppose a person owns 12 shirts, 5 shorts, and 3 pairs of shoes. And we might ask the question, how many outfits can this person wear? Well, given just this selection here, what do we have? Well, we have 12 shirts. So in our first event, we have 12 different things we could choose. So we have 12 shirts we can choose from. The second event is how many shorts can we choose? Well, we have 5 different shorts to choose from. And then the last or third event here is a selection from 3 pairs of shoes. Right? So we have 3 different pairs of shoes to select. So our total number of outfits we could make is just the product of those 3 things. 12 times 5 is 60, times 3 is 180. And so we see an example of this second rule. And of course, if there are the same number of events in each trial, this just reduces to our first rule. All right. We have one more rule that we're going to look at in this video, and then we'll do 2 more complicated rules in the next video. So our third rule here is that the number of ways that all n items can be arranged in order is, and our notation is n exclamation point. This exclamation point means n factorial. And what is that? That is n times n minus 1 times n minus 2, all the way down until we multiply by 1. And this is where n factorial is called the factorial, or this symbol is called the factorial. Moreover, let's go ahead and make sure we're clear on this. We define 0 factorial to be 1. So if you ever see 0 factorial, that just means 1. We define it to be that way because it makes a lot of other formulas just work out nicely. But if we have a positive integer number of items and we want to determine how many ways we can arrange these in order, we get that calculation by n factorial, which again is n times n minus 1 times n minus 2 all the way down until 2 times 1. So one example you might see something like that in is, suppose we have 8 runners in a race. What are the number of ways that these 8 runners could be ordered in that race? Well, the answer to that would be 8 factorial. Let's look at another example, and that'll be the one that I actually write down here. So example 3 is, suppose you have 5 books to be placed on a bookshelf. How many ways can you arrange these books? Of course, we're assuming that we're all choosing the same arrangement in a sense, and that all of these books are maybe either stacked up on the shelf or they're all set up with their spines facing outward and all next to each other. And then assuming that, then how many ways can you arrange these books? Well, we have 5 books, so the leftmost book could be any one of those 5. So the total number of ways here is n is equal to, let's not call it n. Let's call this number of outcomes or number of arrangements is equal to, well, the first book, the one on the leftmost book, could be any one of 5 books. But after that particular book is chosen, then the next book, so the second to leftmost book, could be any one of 4 books. And then the next one is any one of 3 books, and then any one of 2 books. And then once we've made all of those selections, well, there's only 1 book left. So the last book must be placed at the end. And notice this is our formula for 5 factorial. Right? And what is that? Well, 5 times 4 is 20, times 3 is 60, times 2 is 120. So there's 120 different ways that we could arrange these 5 books on the bookshelf. And that will end this first video on counting rules.